Today's lessons on compound inequalities. First of all, in your notes, let's look what is a compound inequality. It would be if you have two inequalities joined by the words and or. So it is more than one inequality. If you're using the word and, that means that you're going to represent the intersection of the two inequalities. Intersection. What they have in common. If you're using the word or between your inequalities, that means you're going to combine your solutions, or you're going to union. And so we use that U symbol versus the upside down U with the and situation. When you have an and statement, the value must satisfy both parts of the inequality. So that's a very key factor in looking for solutions. It's got to work for both parts. If you have an or statement, it only has to satisfy one part. Either part can be true. Two inequalities considered together, again, form what we call a compound inequality. So if we have an inequality, 7 is less than x, and x is less than 15, we can rewrite that as one inequality. In order to do that, remember how we talked about the variable needs to come first, switch the symbol, and then the number. So we would rewrite this part as x greater than 7 if we were going to graph it. But when we're writing it to combine it together, we have the x in between the two numbers, the smallest number and the highest number. This compound inequality, -3 less than x less than 5, is talking about a value for x that is between those two numbers, between -3 and 5. -3 less than or equal to x less than or equal to 5. When we switch the symbol and have the equal marks, then we are including the -3 and the 5 as part of the result. More compound inequality examples. We have 3x greater than 2x minus 5 greater than 6. And we have 5x minus 3 greater than or equal to 4, and -2x plus 6 greater than -1. Both of these examples represent an and situation, which means it is the intersection of what they have in common. 1/2 x minus 7 less than 5, or 4x minus 2 greater than 6, where there is the or between them, represents the union. More on compound inequalities with the word and. When you have the and between them, remember that we're only looking at where both are true, so that's the overlapping or the intersection part. Remember, the graph of compound inequalities with the word and means that we're looking at the intersection. The intersection is what they have in common, where you will see them overlap. The symbol that can also be used to replace the word and is an upside down U. Compound inequalities with the or. When a compound inequality contains the word or, that means that either part can be true. It doesn't matter if it's both of it, it's just either part. Compound inequalities with the word or means to union, combine the graphs together. The symbol is the U. Here's an example. We want to graph the solution for this compound inequality. It includes the word and. We're going to graph each inequality separately. So with the first one, we're going to graph label 10 and values that are less than 10. That would be an open circle shaded to the left. The second graph is the second inequality. So that would be at the value 5, open circle shaded to the right. The area where the two graphs overlap are between 5 and 10. So the solution is the union of those graphs. So we have an open circle at 5, an open circle at 10, and shading between those two values. Now we're going to do an example of graph for a compound inequality with an OR. You don't have to do the 3 separate graphs with the compound inequality and the OR situation, but you can if you want to. If we did the first one, we would want to flip that inequality around. So we would have x greater than -3. So at -3, we have an open circle, and we shade to the right. The second inequality, x is greater than 0. So at 0, we have an open circle, and we shade to the right. Now this is an unusual circumstance for an OR situation. In this particular case, when we combine these two graphs together, the first graph overtakes the second graph, and so the solution is from -3 to the right. All of that is the solution. Again, this is an unusual graph for an OR situation. This is not a typical graph for OR situations. Let's look at another example. Not every inequality is going to be completely solved. So the first thing we would have to do is to solve each inequality. This is still an AND situation. But we would solve as we normally would. We would add 1 to both sides. So we get 3x is greater than -27. We would divide each side by 3 and end up with x is greater than -9. The second inequality, we would subtract 7 from both sides. We end up with 2x is less than 12. Then dividing each side by 2, we would end up with the inequality x is less than 6. Graphing each solution. There's first inequality, x is less than 6, would be an open circle shaded to the left. The second inequality, x is greater than -9, open circle graph to the right. We can see the intersection of those two graphs. So this would represent the solution at the bottom. The values between -9 and 6. Another example with an OR situation. Again, the first thing we need to do is to solve each inequality. So we would subtract 9 from both sides. We have 3x is less than -12. Divide by 3, we get x is less than -4. On the other inequality, we subtract 1. We get -2x is less than 4. Divide each side by -2. We get x. Remember, because we divided by a negative, we have to flip the symbol, and we have -2 for the second answer. To graph that solution, we would have an open circle at -4 and shade to the left. An open circle at -2 and shade to the right. This is a more typical graph of an OR situation than the one we had previously. Let's try this next problem. We have 2x is greater than x plus 6, and x minus 7 is less than 2. This is a combination of the word and. So we are looking at where their solutions will overlap. But before we can get there, we've got to solve each inequality first. So I'm going to subtract x from both sides, and x is greater than 6. I'm going to add 7 to each side, so I have x is less than 9. To graph the solutions, I would first graph x is greater than 6. Open circle, shade it to the right. The next one, x is less than 9. An open circle at 9, shade it to the left. Where they overlap is between 6 and 9, so the actual solution is between those two values, 6 and 9. Again, the solution is the part where they overlap. Now, if we were writing this as an inequality, we would actually want to combine these two inequalities together. So we need to flip the smallest value around. 6 would be less than x. And then we can include the other part of the inequality, less than 9. Smallest value always goes on the right. Largest value always goes on the left. The x is in between. If we were using interval notation, we would have the smallest value up to the largest value 9. Since they are not equal, we would be using parentheses for the interval notation. For this last problem, we have another and situation because we have one combined inequality. We can separate this into two inequalities. 3 is less than 2x minus 1, and 2x minus 1 is less than 5. We can solve each of these separate inequalities. So I would add 1 to both sides. I would divide by 2, and I have 2 is less than x. Now, if we want that in the correct order, we need to switch it around and have x greater than 2. The second inequality, adding 1 to both sides, we have 2x is less than 6. Dividing each side by 2, x is less than 3. Now, please keep in mind, with this particular type of problem, you could solve this inequality altogether. If I want to undo the minus 1, I would add 1. So I would add 1 on this part and on this part. So I would have 4 less than 2x less than 6. In order to get the x by itself, I would have to divide by 2. So I have to do that in each part. So I have 2 less than x less than 3. Either way, we're going to come out with the same answer because when we rewrite these together, smallest less than x less than largest, we still get the same value. Now let's look at the graph. That means if we're graphing x is greater than 2, we would have an open circle at 2, and it's going to the right. If we were graphing x is less than 3, we would have an open circle at 3, and it's going to the left. The area where they overlap is between 2 and 3, and so that represents our solution. I have 4 problems left for you to complete on your own. Be sure you put these in your notebook and show all your work. Be sure you're writing the graph, the inequality, and the interval notation for each.